A couple of episodes, we had a chat with Hayden about machinery, and we actually asked you guys, what would you like to see in a machine if for like some hypothetical reason there was a machine to be coming out from the WORX Plus factory? And we got hit with a whole bunch of suggestions. Not saying that that's when we started building a machine, but a week later we told you, hey, guess what? Yep, a new grinder is on the way. Takes a lot of years to build a grinder, and there's been a lot of work, a lot of progress made. And today I'm actually going to take you to check in on the fellas who've been assigned the task of making this new grinder and get some intel on what they're up to, what's in the machines, and see if we can sniff around and get a bit of an idea of what's in the pipeline. So come on, take a walk with me and we'll go see the top secret operation.
All right, come on. It's us. Okay, if we come in? Cool.
Tim, we're going to go and have a chat to Hayden in a moment, which, I mean, just about everyone already knows.
Please do.
Hayden.
The sooner you get out of here, the better, Josh.
We want to talk to you about a couple of things. You were involved in the project for the new grinder from the very earliest days. And I wanted to come and talk to you and get from the horse's mouth a little bit of the background of the starting point. What was the original brief on the machinery, and I guess what motivated some of the original, the biggest points of what you want to achieve with a new grinder?
Yeah, okay, Josh. I would probably answer that by saying we made the first machine in the late 90s. We ran that platform essentially to 2010, where our connection or involvement with that product essentially finished. And from that point on, we were just more specialising in diamond tools and developing tooling and applications. So I guess there wasn't a lot of development in the grinding machine marketplace in that 10 years. And then in the last 15 years or so, there's been a lot of development in diamond tools, particularly in the resin tooling products, metals as well, but the resin tooling products. So what that means is that we've essentially got a whole range of different of tooling and tooling possibilities that don't really suit the machines that we built in the earlier years, but also what we feel were some of the iterations of machinery that have come out since then. So really the technology in the abrasives are kind of putting pressure and driving a need to have some different type of development, at least as we saw it, in the piece of equipment that drives those tools over the floor. Because at the end of the day, it's the tools that do the work, right? Mm-hmm. It's those cutting edges in contact with the concrete or whatever happens, you happen to be grinding, that's doing the work. The machine's just the workhorse, that's the powerhouse, the power unit to actually enable them to do their job.
So effectively what you're telling us is that the development in tooling has pretty much outstripped the capacity of the machine, and we could actually get more out of the tooling if we had a machine that could actually take it further.
Yeah, and obviously the market moves.
Yep.
Economic factors change. We've always been about productivity and seeing, look, we know the greater the productivity, the more accessible the product becomes across the marketplace. Mm-hmm. So the better production and the better productivity and the more skill that's out there, the better it is for the industry, because the product becomes more viable, and it becomes more viable for more applications or environments that it may not have been 15 years ago.
Sure. Okay. Getting a bit off topic there. I just want to talk about the machine, right? Let's go back to the brief, the early brief, when you put pen to paper and said, okay, turns out we're going to be building a new machine. All right, we know that the abrasives technology is outstripping the race of what the machines can do.
Yep.
All right, putting pen to paper, what does the brief say?
Well, essentially, a lot of it always, as you would know, comes back to power to weight ratio, okay? We know that for diamond tooling, there's an optimal amount of pressure, whether it be a metal or a resin that we're sort of shooting for, and it changes a little bit between metals and resins. But we know there's an optimal range of pressure for a diamond tool, and like we just mentioned, they're the ones that are doing the work. So we want a certain amount of pressure, and a certain amount of pressure is going to entail a certain amount of power to actually drive those tools across the floor. It stands to reason that the more of those edges or the more of those tools you can put under a machine,
faster it should cut, right?
You got more cutting edges, right? So the faster it should cut. But if you want to keep that sweet spot with the amount of weight per tool where it needs to be, then obviously you need a lot of pressure or additional pressure and weight to do that. And then, of course, you need
more power.
More power because you're powering more cutting edges. More power means bigger motors. Bigger motors mean more weight because there's more copper. So you get into this vicious cycle of we want the power, we want the weight because we want to run more cutting edges, but we start making something that gets well out of control as far as
massive
size and weight
and power requirements.
Yep.
All right.
Yep.
So where did you stop?
Well, we never actually started, Josh. Where do we start? Well, we actually had to start looking around for these machines are a trade-off, okay? They're a mobile machine, so you can't build a machine that's just ideal for once it's on the actual factory floor or the concrete floor, whatever you happen to be grinding. You've got to get it there as well. There's always these trade-offs between power availability, transportability, or mobility, and obviously productivity. And then, of course, how are you going to run this thing with an operator?
Yep.
Is it going to be pushed by the operator's weight and their own strength, or is it going to be driver assist or user assist or like radio control, all that sort of stuff? So there's just one trade-off after another that you're always working with.
Yeah, okay.
You can't actually make the dream product necessarily unless you don't tick, unless you're prepared to forfeit ticking some of the other boxes along the way.
Yeah, yeah, and I guess a big part of why we're doing what we're doing is so that everyone can understand what those trade-offs were, why the decisions that you made were made, so we can fully comprehend and appreciate why we've got, at the end of the series, the product that we have in front of us.
Yep.
So let's get more into that.
Yeah. Look, for us, I guess the high-level ambition, desire was to have as much power as we could without the thing getting too heavy and ridiculous as far as that was concerned, because we also know that power is a funny thing, okay, particularly when it comes to electric motors. And we know that, having just talked about diamond tools a little bit, not only do they have certain pressures that they have certain speed ranges, okay? And we know that within the application between metals and resins, there's quite a wide range of speed. When I say speed, RPM or actual linear speed of the diamond tool over the floor. We want that range because we're using the one machine to do lots of different applications with different tools. So you may want low speed for a tool, let's say like a PCD or a bush hammer, where they don't require high speeds. In fact, high speeds actually can be detrimental to their lifespan. Through to the other end of the spectrum, where we have like our Tempo XDs or some of our resin pads, where we want really high speed, okay? So you need a machine that has the speed range, but we also know that with speed range comes loss in torque
or
as
trade-offs.
well, okay?
Yep.
So we want the speed at one end and we want the power at another end. But of course, we want to be able to put as many tools on at the high speed as well, because we want to stick with that rule of getting as many cutting edges under there on the floor as possible. But when we start doing that, we need more power. When we overspeed a electric motor, we can go from full torque to half torque by doubling its speed. And we know that some of the machines out there today in the marketplace, the motor's been designed to run at 50 hertz, but they're being run up to 100 hertz. So essentially you can have a 15 kilowatt motor at 50 hertz, which is quite a slow RPM for any grinding contractors' considerations. You run up to full speed at 100 hertz, you've now got a 7.5 kilowatt motor at the high speed, right?
Yeah, right.
So you still need to try and to pack as much power into the machine to help us at that high level and give us as much options up there as we can, and therefore as much productivity, because that's the paradigms, they're the parameters in which we're working. So it's really maximum power that's practical, that's accessible, that's efficient, and doesn't actually make a machine unpractical from a transportability and mobility point of view, or using it.
So you've actually really had a good long hard think about this.
Not really. You only just asked me the question.
Gee, I thought this was going to be a really short conversation about, we've got a couple of pulleys here and some discs here, and we put a bigger motor on it and have at it. It's going to be fun. It seems like there's a lot more involved in it. And is this a case of has this been a project that you and Hayden have been on your own? How many people how much work does it actually take to make a machine? I mean, I thought it'd just be a matter of, those cutting a few plates, getting a few pulleys turned up and choosing which motor you want, and off we go.
No, there's a lot of people involved in the project, to different degrees and different inputs, but there's obviously our own internal people like Hayden and myself, and you've been involved in the project, and we've got other people involved in the design team. We've got consultants that we work with as well. So there's a bunch of people involved, and we need to recruit a bunch of people because I don't have that many credentials in many things, Josh. Other people are very important to me. So, and obviously this machine is far more advanced than anything we've made in the past. So we need to draw on competencies and skills of people that are even outside of our industry when it comes to some of the technologies and some of the componentry and some of the systems that we're trying to integrate into this machine.
Okay. Far out. All right. So it takes a bit more work. How long, Hayden tried to give us a bit of a timeline as to how long it had been going for. If you had to put a finger on a time when this actually started?
Well, I think it's never really stopped.
I'm glad he said it's never really stopped. I thought he said it's never really started.
It never really stopped. I mean, we were obviously developing a certain series of machines in King Concepts, the 820, the 680 and the 530. We'd started working on some other projects that got canned at the time when we became part of the Husqvarna organisation. But I think our mind has always been in that space of advancing. Obviously, we did the Big Kev project with the dual head grinders. We've been playing with lots of things over the years, whether it be playing with the amount of different heads of the machine, big blocks, which a lot of people have actually seen come to the marketplace. There's lots of things that we've actually been, pulley ratios inside machines, disc sizes. There's a whole bunch of things that we have been inquiring about and playing with sort of on the side, and it's just part of that curiosity to continue to see what might work, what might make a difference, what might make a benefit to the marketplace. And I guess I would say this project has really been going, ever since the King Concepts days, but probably formally from probably the last 10 years at least, we've been playing around with these sorts of things as we explore different opportunities and different ways of reimagining essentially the machine and what it can do.
Well, that sounds like a lot of hours. A lot of hours. Well, we're also going to be having a look at some of the previous concepts as we go through. It's not just going to be a focus on what we're building. We're going to talk about some of the things that didn't make the cut. Yep. So hopefully we get
plenty of those.
Yeah, I was going to say hopefully we get to see a few more of those along the way if we can find them.
It's where a lot of the time goes. There's a lot of stuff that we sell here that totally works, but there's been a lot of stuff that doesn't work as well.
So if you're saying if we hang around the bin, we might see more going into the bin than we see going out the front door. That's all really good. I have a question from a viewer, and they would like to know how many heads does it have, Tim? The
How many
new, the
heads?
new machines that come out, how many heads will they have?
How many hats does this person want to wear?
Tried, guys. I tried. We'll get there. All right. If you're not going to tell me that, 10 years, seems like there's been a lot of people involved internally, externally.
Yep.
I'd like to know what some of the major challenges have been, or the sticking points over that nearly decade that it's taken to get to this point.
Some of the major challenges are we're doing a number of different things at the one time. Okay, so without getting too far ahead in the series,
Go ahead, be my guest. Go as far as you like.
We've learned a lot of stuff since the late 90s when we first designed and built a machine. We've learned a lot about how to make a product. Obviously, we've learned about where the Achilles heels in our original machines were, whether that be from a reliability point of view or certain things we did that could have been made maintenance and servicing a whole lot easier and those sorts of things. We've talked about power, we've talked about the diamond tool development. So probably a lot of the difficulty is trying to combine all these things together. Look, we grew up in a push machine economy, right? There's a much different expectation with regards to working hours and working effort and operator assistance and operator ease and all that sort of things now. So all of those things have been challenging because we've had to adapt to that. Plus we've had to rethink some of the problems or solutions to our previous problems. Mm-hmm. So we're trying to package a whole bunch of different things. It's not just been, we just want to make a more powerful version of the previous machine. We want something that's going to be, easier to use. That's going to be, whether it be from a maintenance point of view, whether it be from a user assistance point of view, transportability. All the old ways that we used to get machines in and out of vans and onto trucks and so forth. You just can't get away with that kind of stuff anymore, Josh.
A couple of milk crates and some timber planks.
Yeah. So I think probably the complexity has been, I guess, the ambition to change a lot of stuff, mm-hmm. not just one or two things. And the other thing that's been really challenging for us is, there's been a few, but some of the things that we've been looking to do is finding the competency. We're still a very niche industry, and some of the solutions that we want are quite niche. And when you go out to the industry and you go out to consultants that are used to sort of dealing in the mass consumer marketplaces, there's a big disconnect sometimes between what we're trying to do and what they're used to delivering. Mm-hmm. And some of it's been trying to push external competencies past points or that they just don't have. So some of that we've actually had to end up developing in-house so we can actually get exactly what we want and the way we want it. So there's been time and development that's gone into actually essentially getting the right people. It's funny how things come back to people all the time, isn't it?
All this technology and we still keep coming back to people.
Yep.
Someone's got to develop it.
Yep.
All right. Speaking of development and people, I want to go and check out the power unit on this thing. You've evaded a lot of the questions that I've asked, been very indirect. I'm hoping that I can go and have a chat with Hayden.
Oh, he's a pushover.
He's a lot more direct, and I'm hoping that he's going to be able to tell me a bit more about the power. I've asked you questions on the design of the machine, and I'm getting the feeling that you've kind of missed your calling. Maybe you should have gone into politics. Hasn't answered a darn thing with a straight answer. Something short would be appreciated. No, I'm only kidding. I'm being facetious. What I'm gathering here is that there's a whole lot of stuff here that goes into making the machine, and there's already been a ton of time invested into building a machine, and this isn't the one we're talking about specifically, hasn't even been the first one that's been developed.
Mm-hmm. Yep.
So there's been a massive amount of time and development, and while you're doing this, obviously the rest of the world's moving along at the same time. So I'm assuming there's a lot of technologies that you're actually able to grab and put into it that you didn't foresee 10 years ago, which would have an impact on...
Absolutely, and that's always part of the tension of doing something like this. There's there's a wish list of things that you got a whole lot of good ideas. Some of them you can do now. Some of them you got to wait for technology to catch up or for technology to become more accessible or more cost effective for a product that we're making, because our volumes are so much lower than cars or computers or something like that. So there's always that gap. And just because we're bringing out this product now doesn't mean we're not already thinking of what future iterations there will be and features that can be brought into it. But that takes time, and it takes sometimes it takes some change in the marketplace as well for us to be able to do that.
Yeah, I mean, because if I look at the brief that you've got written there, the original brief, it actually says that it needs to be able to bake cookies, but these days they actually just get delivered.
Oh, well, this one will be half baked. Is that close enough?
Yeah. All right, Tim. Thanks for your time. We're going to go and see Hayden and see what he's got to say about horsepower, size, and maybe we can get some actual, credible information out of him.
Nay!
And Hayden should be just here. Hayden!
Josh.
What do we have here?
Just, looking at some things we've done in the past. See if anything inspires some new ideas.
Well, we've just been talking to Tim about the new machines. He talked about the sizes of platform, that sort of stuff. When I started drilling him for horsepower, he said, come and see you. And
You're in the right place.
I'm pretty happy with what
That's
I'm
right.
seeing here.
I mean, look at what we got.
I love a machine that's built around a big motor.
Shouldn't everything be built around a motor?
Yeah.
That's the heart and soul of something.
It's kind of like building a race car, right? I love those race cars that are just built around a motor and a set of wheels, and then everything else takes
No one
form
cares
around
about
that.
anything else, just
No.
how much horsepower can I
That's
have.
what we've got going on here, right?
Exactly. I mean, this people have seen this on a shelf a long time ago, but this is horsepower right here. This is 30 kilowatts. I mean, when we talk about what machines currently in the market have, we're talking 11, 15, 30.
So hang on, is this a new machine?
That looks relatively new, doesn't it? It's
This is not the new grinder.
too big. Oh, back to the drawing board for me then. No, this is not. This is the 1100 that was produced. Well, not produced, played with. Early 2000s.
Yep.
Again, a development way back when of starting to try and get bigger motors, more performance, more weight on tooling. Productivity.
Because this looks like a pretty big machine.
It is.
It's 1100. Just the head alone weighs 1.1 tons. And this is 30 kilowatts.
Correct.
So this is the line of thinking that we were on, the track that we were on in the last years of King Concepts.
Yeah.
Now, Tim's told us all about the disadvantages of having really big machines,
Big, heavy,
the way that
clunky.
we were building them back then.
Yep.
That's not the route that we're going now.
Correct.
So he isn't this motor.
Wouldn't be? It'd be great, wouldn't it? 30 kilowatts? Would you like 30 kilowatts?
I love 30 kilowatts.
Yeah. I just
You guys would love 30 kilowatts, right?
I just think it's a bit big to fit on a machine. So, luckily, since this was made, technology's come a long way.
Yeah, okay.
Yeah, I mean,
Well, tell me.
how
many kilowatts?
how many kilowatts?
How much power are we going to be running?
A wee.
Just
A wee.
tell us.
Well, I'm going to give you a good example of, back then, 30 kilowatts. Look at 22 was probably around the same size, a little bit smaller.
Yep.
Technology nowadays has moved around to this,
How many kilowatts?
22.
22 kilowatts.
22 kilowatts. 11. 22. 30.
All right. 22 kilowatts.
22 kilowatts.
So tell me, we are not using a big iron machine or motor like this one.
Correct.
30 kilowatts.
Yep.
We're moving away from just bigger, more brawn, and we're going to more intelligence.
Yes. Yes, we are. Certainly, it is the newer motor technologies, like a permanent magnet motor. Biggest saving on those is you get a weight difference between them.
Uh-huh.
So as Tim's been talking, heavier machines, they have their advantages for getting productivity on the ground, but you still need a big enough motor to turn the discs with that much weight on it.
Yep.
So it's a real balancing act, and finding that sweet spot is not easy. as guys already find with machines, with weights, putting weights forwards, backwards, neutral, it is all around doing the same thing, getting the right weight over the tooling. So, in essence, if we're going stronger machines, more robust machines that start looking a bit like this, from a size and people are confident they're not going to break down and they're going to last and do the job, something's got to give from a weight perspective. And we didn't want to tone down the horsepower, so we found these.
So we've kind of gone away from the whole idea of building a car around a motor, or being a bit more intelligent, being more like supercar style building.
That's right. Performance, speed, agility,
Balance. I'm very excited. Anything else more that you can tell us about these types of motors?
Look, I mean, other than the obvious, the weight saving, the size saving is huge. When you look at the difference, even a 22 in this style motor in current days is still quite a lot larger than that.
Yep.
You do get a bit more control out of the newer motors. The PM motors, they have sensors in them to work out where they are at all times. So you get a lot more data coming back from the motor to the frequency inverters compared to the earlier ones. They were all basically looking at what current and voltage am I putting out to the motor and calculating the rest as an assumption. Whereas these have a lot more feedback of actual numbers that the motor is doing.
Okay.
So we get a lot more detail.
assuming that feedback is something that's important to
It's very important.
the design team for some other features that we're going to be covering later on.
Exactly.
All right. So a little bit more about this motor. We've just turned it upside down and I've seen this fancy looking plug underneath.
You've seen shiny things.
I'm seeing shiny
You've seen
things.
shiny things.
Tell me some more.
Look, these motors have sensors built in. So this is communication for the sensors. The motors also have an independent cooling fan. People will ask why. When a motor's running at slow speed under high torque, so what we call slow speed and what the motor thinks is slow speed is very, very different. So a lot of the time when we're in our lower end operation, we're putting a lot of load on the motor, everything's heating up intensely, the motor fan's not spinning fast enough to actually cool it properly. And in the PM motor, it has its own fan built in based off temperature of the motor. So it has a sensor inside the motor that when it gets to a certain temperature, engages the fan to cool it at any speed, any time. So no matter how heavy the grind is that you're doing, it's going to be able to cool it as it wants to, compared to relying on the motor speed to do the same job. So
That is a pretty smart feature.
it is.
I like this.
Technologies.
All right, 22 kilowatts, really smart.
Yep.
When it comes to, I guess, the engineering implications, running 22 kilowatts, this is not going to work in any current platform machine.
No.
So what type of engineering, I guess, knock-ons or implications has this had?
A lot, and part of moving to the lighter machine was having to do a lot of modifications and advancements within the design of the machine. So heavier duty components had to go in, complete different setups of bearings and things like that had to be done. So a lot of extra weight has actually gone into the head for getting it to be as robust as we can, based around the additional horsepower coming in. So making a lighter motor was an advantage to doing that.
Yeah.
Just gives us that flexibility where we can add a bit of steel into something to make it last longer. We can add an extra bearing into something to give it, take the load better. All of these things add up to weight at the end of the day. So being able to put a lighter motor to compensate for some of that weight was great. And in a rough ballpark, it's about 50 kilos difference between its normal motor. So
Oh, wow.
yeah, so it's a reasonable amount.
significant.
Yeah.
Well, prior to coming out and seeing you, I was talking with Tim, and he was telling us some of the, I guess, the goals that you guys were shooting for in the brief. Yep. What kind of numbers that you're trying to hit from a production rate. And I've got a question. I'm thinking about some of what our viewers have asked us already. From a wheel drives perspective, the first generation Husqvarna had 4 5mm screws holding on those wheel drives. How many screws are you going to be using? What size?
As many as I can. I mean, 5mm is good, it's compact. So, if I put 20 of them in, is that the same?
All right, well, I tried, guys. I tried. So with all this additional power, contractors are already pretty well established in their business. Some of them have, up to 5 to 10 machines. Go throw this big machine in the mix. what type of power implications is that going to have on the operation from a business perspective, infrastructure?
Yep. So it's being 22 kilowatts, it is going to require a higher power input. As a general, these PM motors also use a little bit less current, so you can get away with running a little bit lighter on. But certainly, it's when they're going from a 32 amp outlet, there's a good chance that they're probably going to have to go bigger. So generators the same, various generators out there, various sizes. You're probably going to struggle to do this, and the vacuum's required on a 45 kVA. I don't think that's going to work.
Right. Okay. So do we have any solutions to that? I mean, I could see that being a pretty big hurdle if we have to update everything to match.
Absolutely, and that was part of our thinking is how big is too big? Can't believe I said that. But one option would be we can offer customers a 15 kilowatt version.
Right.
Be great. They can still run on their existing power. It's what they're used to running. I don't really see the great benefits in that. A plan that we're looking at is that they can run on both. So
hang on.
That's right. Why not have both? Isn't
What, do you carry an extra motor around and swap them out as required or something?
That's right, hot swap. No, so the ideal plan, which we're still working on, would be that digitally through the inverters, we can change the settings required. So depending on what your power source was, if you were able to utilise the full 22, you bump it up to that. If you're on house power, only 32 available, smaller generator, something like that, you can tone it back down. Just means you don't get the full performance out of the motor for that time.
All right.
But it gives you the option to run both.
Because you mentioned house power, what if I only had 240 volts available?
You can probably run that fan.
All right. Well, that's still pretty exciting. It's kind of like having dual fuel.
Very true. Very true. Very true.
Yeah, that's really clever. I hope that feature works, and that sounds pretty awesome.
It does.
Hayden, you guys are under some serious pressure. Big mission to get this machine at the Water Concrete in 2025. So I'm not going to hold you up any longer. But thank you so much for sharing all that information with us about the new motor that's going on this machine. Very, very excited.
No worries. My pleasure.
Well, I don't know now what I'm more excited about.
I'll leave this one back.
Seeing inside the new machine head, seeing the new wheel drive system, or the radio control, or all of them. One thing you can be sure about though is that you're going to see something in the next episode coming up soon. So stay tuned.